Sigmatropic rearrangements involve a sigma bond breaking in a molecule and the formation of a new sigma bond elsewhere in the molecule. A true sigmatropic rearrangement remains uncatalyzed.
The nomenclature involved in naming these reactions used the general form of I and J.
It's interesting to note that when the sum of I and J is even, the carbon chain is neutral. When the sum of I and J is odd, the carbon chain is charged.
So this is the sigma bond that we're interested in. On one side we have this carbon, and that's going to be the carbon designated to the I, while this one is designated to the J. It would be a 1, so this would be when I equals 2, 3, 4, etc. And same, this is when J is equal to 1, 2, 3, 4, etc. The rearrangement starts with electrons from this double bond moving over here, which forces these to move over here and this bond to break, and then these electrons form the new sigma bond. This is the final product, and you notice that the new sigma bond is between the third carbon for both I and J.
This is more like one of the examples that we've seen in class with the dienes. So on each side we've got the primary carbons, which is where the single bond is, secondary and tertiary, which is where the double bonds are. I3 rearrangement, because you can see that the new bond is formed between I3 and J3.
If we take a closer look at the orbitals specifically involved in the single bond, we see that they are in the same phase. That is what allows the bond to form. The bond breaks to form the transition state. The orbitals that are present in the transition state follow these configurations. In the transition state, there are two sets of orbitals that are in the same phase, which make those bonds permissible. One option is the starting reaction, while the other option gives the final product. When we look at this situation under photochemical excitation, an electron gets promoted into a higher energy level. This forms the HOMO star, which interacts with the original HOMO. Looking at the orbital configurations, we now see that only the original bond is capable of forming. The orbitals on the right-hand side are out of phase and the reaction does not proceed photochemically.
All the leaves are brown, and the sky is gray. I've been for a walk on a winter's day. I'd be safe and warm if I was in Aleya. California's dream.
Take sigmatropic and break it down. Sigma single bond tropic means turn around. Electrons rearranging but not leaving town. 3 carbons away is where they'll be found.